Alright, now that we've finished assignment 6D2, you'll walk into class and you'll see lots of fun, happy friends that we've been memorizing for a while now. We're going to use a lot of the earlier ones that we've started with, because now we're going to apply this the idea of sine and cosine and tangent to degrees. So let's make sure that we have all those things memorized. The physics formulas are new, and here they are down at the bottom. And you can now... And now we're going to move on to section 6.5. That's going to be trig functions involving angles. So now that we know what a degree is, we can apply it to the unit circle. Surprise, surprise, this is 0 degrees, 180 degrees, 90, 270, and all of our fun, happy friends get labeled with degrees now. There they are. And you can also go in the negative direction if you want. You don't have to have these things memorized. I think it's not worth it to have them memorized, but there they are. So if the textbook asks you to find what the sine of 90 degrees is, first thing you do is draw a unit circle, go up 90 degrees, and find and you can report the v value, which is equal to 1. If you want to find the tangent of 135, you got to draw a 135 degree angle that goes this way. That's 45 degrees short of 180. So this is 180. Halfway between 90 and 180 is 135. That's a 45, 45, 90 triangle. We know that's negative 0.71, or the same thing as negative square root of 2 over 2. And so then, therefore, if you want to find a tangent, you have to divide these two. This one divided by this one, and you get negative 1. Surprise, surprise, that also is the slope. This line that you've drawn right here actually has a slope of negative 1. So that's really great confirmation. Cosine of 0, draw a unit circle with an angular measurement of 0 degrees here. Starting from here, you go nowhere. It goes 0 degrees. And you can see that's at the point 1, 0, and so therefore that's equal to 1, because you report the u, the first coordinate, the u coordinate. So here's how they're defined. This, you might recognize this a little bit from geometry. This is sine of opposite over hypotenuse. This is a ka, SOHCAHTOA, cosine of adjacent over hypotenuse. This is tangent. This is opposite over adjacent. But then, of course, we have our reciprocal identities as well. So find the 6 trig function values for the angle shown. If we know this is a point at -3, 4, this is no longer the unit circle. The radius is not going to be 1 because it's just going to be something else. So we are on the x and y axis, and let's find out what our opposite, adjacent, hypotenuses are. We know that the opposite here is 4, the adjacent is -3, or the x and y coordinates of this point are 4 and -3. But you have to do a little bit of Pythagorean theorem to figure out what the radius is. 4 squared plus -3 squared is 25. Take the square root, and you get 5. This is a radius of 5. So the sine is going to be -3, that's the x value, over 5, that's the radius. The cosine is going to be 4/5. And then from there, you can get the others. Sine divided by cosine is tangent, so it's... or maybe a bit easier, y over x. That's change in y over change in x is the slope, so that's like tangent. 4 over -3, 4 over -3. You could put 4/5, negative... Example 4, find the 6 trig function values for the angle shown. So we've got an angle right here, and notice this is not a unit circle. The radius is going to be not equal to 1. We actually have to find the radius. You can use the Pythagorean theorem. 4 squared plus -3 squared is equal to 25. And you take the square root of that, you get 5. So the radius is equal to 5. It's a 3, 4, 5 triangle, if you remember those. So if you're a big fan of SOHCAHTOA, then the x here, this x length, is going to be adjacent. This y leg is going to be opposite, and we've got the hypotenuse. So sine is opposite over hypotenuse, and that's 4 over 5. Or if you want to use this chart, it's y over r. In any case, it's 4 over 5. The cosine is the other one, -3 over 5, and the tangent would be sine over cosine. That's negative 4/5 over negative 3/5 simplified. The fifths cancel out. You have 4 over negative 3. Or if you just want to use TOA, tangent is opposite over adjacent. That's 4 over negative 3. It's probably a lot easier. And I just want to point out that this also happens to be the slope of this line right here. It's a slope of negative 4/3. Boom. The cotangent is its reciprocal. Cosecant is also a reciprocal of sine. Secant is the reciprocal of cosine, and I want you to figure out what that is. So, here, the next example, 5. Here, okay, so here's this interesting thing. We've got a line here. So we've got the line x plus 2y equals 0. And how do you graph that? Like, they might not even tell you, they might not even give you the graph. You'd have to just graph this as an equation. You could solve it for y, know that the slope is negative 1/2 and the y-intercept would be 0, or you could go equation, you could make a table in order to help the equation produce a graph. In any case, you've got to graph the line first, and then you've got to figure out what the radius is from here to this point. You can pick any point you want because they don't give you a point, so there's lots of different points on this line. They picked the point negative 4, 2 because I don't know how they picked it, but they picked it. And so you've got to find the radius between the origin and this point that you picked, and it can be 2 square root of 5. So if you want to find all the ratios, you need to first figure out what the x value is, the y value, and the radius. So that would be negative 4, 2, and 2 square roots of 5. I'm not going to go into exactly all the different ratios. I think you might be able to do that yourself, on the assignment, and I can help you as well. But the new thing here is the line and the point and the radius and all that. I just wanted to show you what that looks like. Before I end today, I wanted to say that I've been to Badlands National Park in South Dakota, and when we got there, I was probably my sister was probably 4 years old, and she got out, and it was incredibly hot. It was like 110 degrees out. We had just been driving for 6 hours to get there. We were only going to stay for a moment. We were actually, there was a question as to whether or not we were going to stay for a long time and do a hike or just get back in the car. My sister got out. She looked at it. She looked at the canyons, and she felt the intense heat, and she was like, "Mommy, these are bad lands." And so my mom agreed, and we got back in the car, and we drove another 6 hours to our next destination on our cross-country trip. Have you driven across the country? Have you been to Badlands National Park? Why don't you tell me in class, and I'll see you then. Until then, you need to start this, just copy the problem list and try the first problem, and then, of course, I'll see you in class.